All right, good morning, everybody. I am showing it is at 10 o'clock, and we're going to get this session started. This is the fourth of our five-part series, this virtual conference in science education that we at NATS, the Nebraska Association of Teachers of Science, have decided to go ahead and put on during this interesting time in our life. My name is Scott King. I'm the president-elect of NATS. And I am super excited today to present Abe Lowe, who works with OpenSciEd. And he will be having a presentation today about the instructional routines and strategies to support coherent student learning. Just a couple of quick things, norms to deal with as we go forward. If you guys would, go ahead and put your state and what grades you teach after your name in the chat box and stuff. It just helps when our speaker is trying to answer questions if he has some context of where you're coming from, both physically and also what grade level you teach, so you can tailor answers to your needs. Please leave your mics muted unless you're speaking. It just helps prevent echo and feedback. And while we love seeing your shining faces and your reactions to what's being said, if you yourself are having bandwidth issues, go ahead and turn off your camera, and that might help you out a little bit. Some of the norms that we have here, first of all, you are here voluntarily for the good of your students, and that is an amazing, commendable thing. And everybody else here is for that same reason. We're all in this together. Everyone's ideas are important and valid. The questions you have and the information you have to share is something that we want to know. So share that information, knowledge, and experience in our chat. Any notes the presenter might give. And during question time, go ahead and unmute yourself and ask the question out loud too. That's perfectly fine. We're going to exhibit professional behavior today, and we're going to be like a proton. Stay positive. And with that, I'm going to turn it over to Abe. I'm going to stop my share.
Good morning, everyone. I'm super excited to be with you all this morning. I'm just going to apologize in advance. I don't think my kids actually realize I'm having a webinar this morning, and my daughter's room is right next door. So in case she pops in to get some cuddles, I apologize. I get just some introductions. My name is Abe Lowe. I'm a science educator at BSCS Science Learning. Most of my work is involved in designing instructional materials and professional learning experiences for teachers to help to make learning more meaningful for students and to kind of help teachers to engage in the pedagogical and epistemic shifts that we want teachers to engage in. Prior to coming to BSCS, I did my PhD at Northwestern, where I had the opportunity to design many of the tools and routines that are involved in the next-gen storyline approach, which is used as part of OpenSciEd. And other instructional materials like Inquiry Hub, like some of you have heard earlier this week. And prior to coming, also after that, I was also involved as an instructional coach at a large middle school, a large urban school district to help to support their rollout of their middle school science curriculum. Just to kind of situate our time today, we just kind of want to talk about why are we talking about instructional routines and coherent sense making. So with the NGSS, we have a number of shifts that we want teachers and students to engage in. We want to get away from just learning facts from a text to actually moving towards trying to construct explanatory knowledge that they can then use and apply to explain things in the world. So we want to have all students engage in the work of actually trying to figure things out. So presenting phenomenon that will help them through the explanation to derive the key understandings that we want them to derive. But at the same time, when we're engaging them in really rich activities, we don't want them to be seen as being disconnected activities. We want them to be seen as that they can understand why, how and why what they're doing is fitting together to help them to achieve their goals, and that the learning from their perspective is coherent. Lastly, we want to make sure that as their kids are engaged in the use of the science and engineering practice and the cross-cutting concept to figure things out, that use is really meaningful. So it's not just a tick box of things they need to do or to have presence in their products, but we really want them to understand how and why using these practices or using these cross-cutting concepts as lenses are really useful for supporting their sense making. So OpenSci is an organization across they have a parent organization, but also as a consortium of developers, and those developers are listed below, that are really charged with trying to design open source materials for states and districts to use to support these shifts with the NGSS. Our focus largely right now is in middle school. So we have piloted 12 different units in 10 different partner states, and 6 of them have been publicly released. And over the next 2 years, through the duration of this year and also through next year, we're going to be hopefully being able to pilot and release a whole coherent set of materials for middle school, with the hope that we would then go either towards elementary and middle school going forward. So what are we going to do today? So my hope is that we would share some instructional routines and strategies that we use in OpenSci and broadly that can be useful in your respective context to support some coherent phenomenon-driven science learning. So we're actually going to play out, so we'll actually engage in some learner experiences. You will humor me a little bit. And then we'll also see how they play out in the course of an OpenSci unit at that very high level. But then we also want to see how can we actually try to implement these strategies and tools in your own respective settings. So we're actually going to share, oopsie daisy, we're actually going to share some principles and tools that you can then use and apply to begin using these things in your respective context. So I hope that's okay with you. If it's all right, we're just going to hold off questions to the end, so we can kind of look across the different contexts with any questions. Okay. All right. Shall we get started? Okay. It's so weird I can't see any of your faces, but I trust that you all are okay. So, so in terms of storyline approach, our units are generally structured in this way in terms of we all have some kind of anchor phenomena that kind of drives our learning, and those phenomena are chosen so that the explanation of this phenomena will help to lead kids to the target understanding that we want them to develop. Once the kids have experienced the anchor phenomenon, kids then engage in some investigations to help them to investigate pieces of that phenomenon that are really important to help to drive their learning. But it's really important because of our goal of trying to support coherence is that we want to make sure that kids understand how what they're learning is connected to each of the different pieces that they're learning and also connected to the broader goal. So we have this routine called navigation that is really central, like the connective tissue that kind of holds things together. But then after kids have learned a whole bunch of stuff together, we want to make sure they're actually putting those pieces together. So we have a routine called the putting the pieces together routine that helps kids to synthesize what they've learned to try to revise their ideas over a period of time. But then we also follow this learning with a move towards problematizing, where we actually try to create that space for kids to actually assess the extent to which they have figured out what they've been charged to do, to think about what they need to figure out next. Or from a teacher's perspective, we might actually create the need for them to think, to deepen their understanding in some way as a means to motivate potential model revision or to pursue additional investigations. So these are, taken together, these routines kind of work together in our instructional model to support student learning. But most of this work really falls under the primary routine around that work around the anchor, because that really sets us up in order to be able to do this work in our storyline materials. And the reason for thinking about the routines again in your respective context is that hopefully you can begin seeing the purpose and the key features of these routines, so you can begin seeing how they might play out when you begin thinking about either designing from scratch or adapting existing materials in your respective settings. So each of our units starts off with an anchor phenomenon routine. Again, so we choose a phenomenon. There are 4 elements to that routine. So we have kids explore the phenomenon, engage in some moves to make sense of that phenomenon, first individually, in smaller groups, and then they come to a group consensus about where people are, how do people agree or disagree. We then find the value in thinking about related phenomenon. What kind of related situations do kids know about in their respective lives or context that might be relevant for helping them to explain the target phenomenon? So again, beginning to see the relevance of kids' own ideas, but also to begin generalizing these ideas, these explanatory ideas beyond the specific context of their anchor. And because we want kids learning to be coherent from their perspective, and we want them to really be driving the ship, we had this move towards questions, posing questions that they have that they want to investigate, and actually had the move towards designing some investigations. So what we're going to do is we're actually going to experience the anchor. So I'm not sure, this email might not have come through, but if you happen to have a sheet of paper handy around yourselves, we're actually going to engage in a really brief moment for the kinds of phenomena that we might use, and then we'll kind of fast forward a little bit and kind of talk a little bit about where the kids would go using some products from our Nebraska teachers that we did during a recent PD. But we want you to think about, as you experience this, like, what were some key moves or strategies that you saw evidence in this routine that could be helpful for supporting kids' sense making and why? And we'll have a chance to reflect at the end, but I just want to provide that lens through which we're going to be thinking about our experience together. Okay, so we're going to adopt, this is the anchor that we're going to be using is from a 6th grade unit, 6th grade weather unit. So you might want to channel your inner 6th grader. You might have a 6th grader in your household, or a 6th grader that you're thinking about reaching in your own class. All right, you ready? So I'm going to don my hat on. So, all right, friends, I'm so excited to be hanging out with you this morning at 10 a.m. in the morning. And, you know, I'm celebrating my 2-year anniversary in Colorado. And one of the things that, you know, they tell you about moving to Colorado is the beautiful mountains and the hiking. It's great. But here's the thing, they don't tell you that there are these balls of ice that fall from the sky and damage stuff. So when this happened for the first time, I was horrified, right? So, and of course, when you're horrified, sometimes I go to the Google to figure out what the heck is happening. And it's kind of a dangerous place because you find lots of different things. So I'm wondering, can I show you some of these videos that I saw that might be, and see if you can help me to explain what's going on? I'm going to trust that I can't see your video and then you're saying yes. Okay, so awesome. So what we're going to do is on that sheet of paper that I hope you were able to find, or you can jot them down in your notebook, I want you to do 2 columns. Okay, I want you to draw the things that you notice. These are the things that you're observing, things you see that's happening in this crazy ball of ice thing that's happening. But also, as you're doing that, think about some questions you have about what's going on. Okay, so take a few moments, take out a pencil. I know you might not have one handy, but just try, or just jot some things down. Okay. We good? Okay, so the Google's a scary place. I'd recommend you have someone with you whenever you go into the Google. So here's one video that I found in Phoenix that was in October 2010.
Well, I figured it would. I said I'm not surprised there aren't more windows busted. That was amazing.
I don't know about you, but I want to increase my homeowner's insurance right now. So if you take a few moments and jot down some things you noticed and wondered about from that video clip. And I can't see most of your videos, so I need to make sure you're actually all doing it. So make sure everyone has some of my notices and wonderings on your sheet of paper. Anya, thank you so much for being a good student. Good job. Try to wrap up some of our ideas. Again, we're gonna be doing a fast pass through this just to, just wanna make sure we get the flavor of what we would do with kids. So again, the Google's a very crazy place. So we found another video that was in Manitoba, Canada, that was in June. And these people thought it was pretty cool to actually do a time-lapse video. So every second in this video is actually 1 minute. And they actually were able to give us a chance to kind of think about what was happening before, during a hailstorm, and also afterwards. So so what I want you to do is underneath your sheet of paper, what we would have done, we would have shared some of our ideas. We're just gonna do that at the after this video. So just draw underneath your notice and wonder chart, and we're gonna watch this video. And again, think about what are some things you notice and wonder about. Okay. Let's take a few moments to kind of jot some ideas down. If you weren't distracted by that cameraman like filming his car. Write down some notices and wonderings you have about what you saw in that video. All right, sixth graders, we're gonna come back together. If you can whip out your chat window, what I wanna do is I wanna kind of share some of your ideas about what you saw happening in those videos. So we're gonna start with a notice. So I want you to do is take a moment in the chat and just actually write down what are some different things you noticed across the two clips, and just jot a few things down in the chat window. If you've already jotted some ideas down in the chat, look at other people's ideas as they're going through. So if we look across, right, there's lots of different things that people have raised, right? So some things about different levels of intensity. That, oh, I love that people were affirming other ideas that you saw in the chat. That's awesome. And oh, Jill saw some reflection of clouds on the windshield in the storm. That's pretty cool. Oh, Carrie saw that too. That's awesome. And the violence, the different sizes of the hail, the different balls of ice. Oh, Wanda noticed it was sunny, cloudy, and then the hail came from the sky. Did anyone notice what happened after the storm? Did anyone see that a progression at all there too? Yeah. Okay. So then Carrie's noticed sunny, storm, sunny. Okay. I want to see, so these are some great noticings that we would normally chart this down on a sheet of paper as we would go through. Oh, Sean noticed it stopped quickly. That's crazy pants, isn't it? Like it starts so suddenly, people are scrambling and then it just stops. I wanted to see if you had some questions you had about these phenomena. So I wanted to take a moment and type the questions that you wrote down about what you thought was happening and why. Interesting. Take a moment to kind of look across some of the different questions that people had. So there's lots of questions about like, how does hail form? How does it get so big? Some people thought about the temperature. That was interesting, right? Like it seems sunny, and then like it's all of a sudden starting to cause these balls of ice to form on days in which it was sunny. That's kind of strange. Oh, so a question about textures, about what it looks like. I actually want to know a little bit more about those hailstones. What caused the extra force? I know it's a little crazy. That Phoenix one was a little tripping, right? So what we would then do is we would then take these questions and these ideas that kids are observing, and then kids would then have the opportunity to kind of make sense of what they thought was happening. And we're not going to give you that much time to think about this, but we want you to think about for like 3 minutes, 2 minutes or so, just like what are some ideas that kids might think about that might help that lead to this kind of event to occur. Because you guys have already talked about this as being hail, that we would define this as being a hailstorm, like in terms of what causes hailstorm to occur. But we would use this particular scaffold to help them to think about what happened prior to the storm, actually when the hail is actually forming, and then what's happening afterwards. That might help them to think across time and across time periods what might be happening over the course of the storm, or that might give rise to the storm. I just want to give you some moments before we actually show you an example of a model, just to take a few moments to kind of think for yourself about what you thought might have been happening as a moment, as a way to compare your ideas. Okay, so hopefully yeah, that at least I had a chance to think about a little bit. So it's very intentional to have kids think about using pictures, symbols, and words to describe their ideas, because we want to create that space for kids to think about. Actually, we're gonna zoom out. We're gonna pop out back out of sixth grade hat. We're just gonna now be as teachers and as we go through. These instructions are very specific for particular reasons, because we want to help kids to create ways and spaces to make visible their ideas. A lot of the ideas of phenomena that we are engaging with, particularly in the secondary, involve mechanisms that are not visible. So we want to create this space for kids to be able to think about at different scales and different, especially in this case would be time. Also things at what's happening at the particle level compared to what's happening at the observable at the macro level. We would have kids do it first individually, kind of like what we did really quickly with you all. We'd have people share and care in small groups, again, to see what ideas are consistent, excuse me, and then think about it as a whole group. And we would actually do a group consensus model. So this is the consensus model that we actually constructed a few weeks ago in Nebraska with our teachers. We had 3 posters that kind of corresponded with what happened. But you'll notice in the first poster, there's this kind of barrier about events that were happening right before it started hailing that people thought was a pretty critical event, where rain started falling. You'll see some zoom in bubbles that kind of talked about what's happening at the particle level, that distinguish between what's happening in colder areas versus warm areas, because they were thinking about there had to be somewhere that was cold for this ice to form and to look crazy pants that are occurring on a sunny day, but they're not sure why or how that happens. And then we have the actual hail that's happening. We saw wind that's forming, the bouncing that we saw happening there. But also some people saw some steam that was occurring off the houses in the third clip. So maybe that might have been some indication about what might have been in terms of temperature or what processes might have been happening in those things. An activity structure that's pretty important for helping to come to consensus is what we call a scientist circle, where we have kids gathered around and we actually have kids share their ideas. And so it's important for them to share their ideas with another person, so they can actually report the group's findings, because that kind of helps to streamline that work. But it creates a space where I wouldn't necessarily be standing there, right? But in terms, I would be sitting, kind of, my purpose would be kind of documenting kids' ideas, but it's really about the kids having equal ownership, and I'm just part of that circle with them. And we have some norms that kind of help to govern that act. But then we would ask kids actually think about related phenomena. So again, we're trying to connect. We don't care necessarily always about that one anchor phenomenon. We care about the kids are thinking about the ideas that are foundational in trying to explain that phenomenon. So we have this move towards explaining related phenomenon to help kids to be able to generalize, again, across those ideas. And see, here are some of the different ideas that we had for precipitation events that have lots of precipitation over a long or a short period of time. And we brainstormed these ideas. And then we took those questions that you guys had written early on the Notice and Wonder chart, and all throughout, we asked moments where, after it come to consensus, like, are there additional questions that have come to mind? So it's always a product that's always being added to. We then asked kids to then put those questions on individual sticky notes, and then we actually post them on our driving question board. So this is actually a final product of what we would do. So you'll notice that there are individual questions, and you can see a lot of the questions are similar to the questions that you guys raised, right? But there would be the move of trying to categorize those questions and actually to create category names to help kids be able to think about the clusters of questions that are going to be driving our learning. We then are in a scientist circle around the driving question board, and we actually come to consensus about where do we think we should go next? How can we investigate some of our questions? And then, so that's another move that we use. You'll notice too here is that the driving question board is actually on the initial consensus model. And that's for very specific purposes, because we're trying to think about questions we might have about particular aspects of the phenomenon. And sometimes it's helpful to actually put those questions directly on the consensus model itself. You can either just choose to then move those questions off of that model later on. But this really helps kids really think about, especially in sixth grade or earlier grade levels, or the first time you're ever doing it, to really think about the parts and relationships and processes they might think about that give rise to the phenomenon. And that's one of the reasons why we use this particular structure here. So that's essentially the anchor phenomenon routine. And I want to kind of create this space for us to kind of reflect a little bit. So those are the 4 elements that we showed that picture really quickly earlier on. And we want to just kind of create that space where we just really take a few moments to just reflect a little bit about what strategies you saw or tools you saw evidence in what we just experienced super quick that might be helpful for supporting kids and making sense of that phenomenon. Let's take a few moments to think first. So could we leverage the chat window to kind of talk about what were the things you thought would be most important or really helpful for kids? Just put some of the things that came to mind for you in the chat. If you finished your ideas, take a look at other people's ideas in the chat. Yeah, so there's lots of different opportunities for kids to think about their notions and wonderings, a lot about, a lot of people thought about the related phenomenon to kind of see why you never ask, I think what Scott said, you never ask why they need to know something so they can see its applicability across context. A lot of people thought about the different ways in which we're having kids share and share their ideas with one another. Kath was talking about thinking time, like creating that space for kids to really think about their ideas and those individual spaces is really intentional and super important. There was a question that that Wanda raised about thinking, or in terms of, I'm not sure one if that's like initial explanations. Is that what that is?
Yes, initial explanation.
Yeah. So in this routine, we try to have kids focus really on what it is that they're trying to observe. So they kind of take stock, so that everyone kind of comes to agreement about what is that we're trying to observe. Because what we found is if kids are thinking too much, at least in this day, at least in how we've been trying, at least with Open Site, is that if kids are thinking about the explanations too quickly, they're not then focused on then the observations and the questions. And then so the conversation becomes less focused about what kids think, and we want to really think about those ideas once we've thought about them together, is the initial pass. But again, based upon how often you've done this with your students. I know, Wanda, you've done that with your kids quite a bit. That move to think jotting down your initial ideas might not be a bad thing if the kids have focused on the prior things at first. Another question that we had really quickly was that people were asking about the sticky dots on the Post-its on the driving question board. We have an activity that helps teachers to think about how the questions can be used to drive learning in the storyline. So those numbers are actually the lesson numbers where questions are going to be partially addressed in the unit itself. So it's a means to kind of think about how you could potentially frame kids' questions, use kids' questions to motivate investigations, but also to think about feeling that if we are going to be saying that our units are going to be driven by kids' questions, that we can actually have sufficient confidence that the question the kids raise will be addressed by the unit. So that it's an exercise we do in PD that you could actually do with a version of that with your students. Okay. So what we're going to do is we're going to take, that makes sense. We're going to take a few minutes. I'm going to keep track of these questions. There's this question that isn't mentioned. I just want to make sure for the second half, I want to talk a little bit about how you might begin operationalizing some of these strategies in terms of this unit, and then also in other contexts, especially if you're not using OpenSci, you're not a middle school teacher. So we've already talked about this. I'm not sure, Scott, I'm not sure if people were able to, if got this, because I said this late last night. But there's a bit.ly link on the slide. So it's bit.ly/weather-storyline. I was trying to put this in the chat. I think I can. So this is a storyline that all of our units produce, and a lot of the units that use the storyline model also have some kind of parallel product in which we outline the question that's driving our learning, the question that kids are going to be wrestling with, what kids are going to be figuring out, how are we going to represent some of these different ideas. You can see how their ideas might develop over time. But there's this part that no one can really read on this slide unless you're really kind of squinting here, which is this notion of navigation. Like that's that connective tissue for what is going to be motivating us to go from one lesson to the next. So a lot of the questions you guys were raising about how hail forms, like what does hail look like, those sorts of things, we actually do some investigation, thinking about some of the conditions that under which hail form would be the next place that we would go in the unit itself. So all the units have these investigation lessons in between, but they all kind of lead up into these putting the pieces together moments where we revise our ideas. So you can begin seeing how some of the representations and how some of the ideas of what they figure out kind of aggregate over time and are represented in these models. And again, these storyline documents kind of show an example of what it could look like. And there are periodic moments of putting the pieces together through a storyline. And we have these big chunks of the unit, and obviously you can see that it's 22 unit lessons long, right? So we're putting pieces together at lesson 6, one at 13, and then one that kind of does a whole other half of the units as itself. So here's just what a storyline could look like at a very high level. But how can you do this yourself, right? So like if you're in a unit and you're not teaching Open Sci-Ed, you're not teaching middle school, or you think Open Sci-Ed is awesome, you drunk the Kool-Aid, and you want us to think about how you can do this in your other settings, right? So how can you begin doing this? So the purpose of the next part of the talk is think about some of the high-level principles and tools that you can potentially use to drive that learning. And there are 5 questions that there are lots of tools you can go to, right? So in terms of when we did this work with our early cohort, our first cadre of teachers in 2012, right? We had lots of different tools and processes that we're trying to develop here. But it can get a little overwhelming by the scope of that task. So what we're trying to do is try and distill 5 principles here that questions that you can think about to kind of guide that learning. So the first is you need to think about what's the goal of the kids learning that you want kids to be able to engage in. So thinking about the performance expectation or sets of performance expectations that you want kids to wrestle with. So performance expectations are things that you need kids to be able to do. and not just know. So it goes beyond just content knowledge. So in the NGSS, you have the SEP, which is in blue, the disciplinary core ideas, which are in orange, and also the cross-cutting concepts in this case, which are in green. And so we leverage cause and effect in this unit. So again, you can see the foundation boxes that kind of informs one of the 4 performance expectations that are driven by this unit. We would go through a process called unpacking, where you actually talk about what does it actually mean to actually demonstrate this understanding? Like, what would it look like? A caution, right? So many people think that the performance, the SEP that's present in the performance expectation has to be the one that you use. And that's not the case, right? It was designed to show an example of a way in which you could demonstrate that those disciplinary cores or use those cross-cutting concepts. But depending on your context and the phenomenon you're choosing or the application context, that SEP can actually be changed. So please don't feel that this is what you have to do. The second thing, right, so you have what you want your goal for your learning, but you need to think now about the anchor phenomenon problem context that can be used to drive that learning. And so to choose productive phenomena, here are some principles that you can leverage. It has to be one that the explanation of that phenomenon will actually lead kids to develop and use the target DCIs and the cross-cutting concepts. And you have to be able to figure things out, so you have to use SEPs too, right? But because it's driven by kids' understanding, right? They're in the driver's seat. A question I find helpful to remind myself of all the time is, why should my kids care? Like, why should my kids care about this idea? Which again is the reason why we connect a related phenomenon earlier in the anchor phenomenon routine, because we want to create that space for them to think about connections. The kids are likely to have some ideas and questions about that phenomenon, but because we're in the classroom context, we also need to think about things that we can actually investigate in the classroom, that there's videos, observations, data sets, and that you can actually have the kids wrestle with in order to investigate their ideas. And I know that TJ presented a talk earlier this week about phenomenon, and you can hopefully see that there's a range of ways in which you can present that context for kids to be making observations or to make sense of the world. There's also this case in which you need to check whether or not the phenomenon is actually appropriate for leading to the disciplinary core ideas. So one thing that we find helpful to do is to actually do your own desired student-friendly explanation of that phenomenon. So this is the target for where you're going. This, by all means, is a very shortened version of the phenomenon of an explanation that kids are likely to arrive in this one, right? So we have convection within the air, within these really tall hail clouds. So we actually look at pictures of clouds that produce hail that actually bring it to the high altitudes where it's sufficiently cold enough for ice to form. And also we talk about condensation within the clouds. And also the wind and the constant uplift that takes place due to the warming of the air on the ground. That's what creates the layers. And so in lesson 2, they actually see like layers in the hail. So they add additional questions about why those layers form. But then it's always useful to check the performance expectation to see whether the explanation that you produce is actually aligned with that performance expectation. In this case, our hail phenomenon gets us to the extent to which they think about motion within air masses to lead to weather conditions. But what it doesn't yet lead us to thinking about is the complex interaction between the air masses to lead to the phenomenon. And that's important to identify, because sometimes in cases you actually might want to re-anchor a unit, as you'll see when we look at the larger storyline for this unit. The third step that we've kind of already done as learners, right, is to think about what ideas and questions kids are likely to pose about the phenomenon, right? So thinking about that as whatever age group you're working with, what ideas are kids likely to bring to the table? What connections are they likely to make to other related situations? What questions they'd likely to raise? What we do in Open SciEd, right? So you may not have the luxury of this, but what we've done is we've actually vetted these phenomena. We actually give kids an interest survey to see what phenomena might pique their interest. So we've done some initial work on our own. We then pilot it with teachers that have done this routine in the past so that we can really get those ideas and questions. And then we see what might be the most productive context for us to do. So if you don't have the opportunity to pilot, it's at least behooves you to think a little bit about what ideas your kids are likely to bring in questions. with then the hope to then sequence those questions. So if you want learn to be driven by questions, you actually need to sequence them so that the answer to those questions will lead them to thinking about the next question. So this is the process that I've done when I try to adapt materials. Is actually just like our DQB, right? So I actually post questions on individual sticky notes, and I begin grouping them. I do the same clumping that we do with the DQB, but I begin sequencing those questions to think about how, again, we can then create that coherent understanding. But there's oftentimes the point where there might be questions that kids are not likely to, your anchor funnel can only get you so far, right? So what additional things might you need to motivate through different investigations or learner experiences? And so those questions are actually in blue. So if you look at that picture down there, this is work that I was doing in a workshop with teachers. We clumped to red questions that questions that we were confident kids were likely to bring, but we also had some blue questions. Teachers like, I need to get my kids to think about this. How can I get my kids to think about these ideas? Are things that we would do through the sticky note activity. And then this is when we would begin constructing that storyline. We would actually begin thinking about what are some activities that can help us to be able to investigate those questions, and what are kids likely to figure out the results of that. But the purpose of doing it in this storyline template, and I'll share with this, I'll put a link onto the website for you as well, is that these ideas at aggregate are going to help you to revise the kids' understanding. But it's important that it's not the time for you to have your favorite activity that you've always done for many years, right? Like, this is the time to think about the intentionality. How are the activities you're choosing to be relevant for helping to explain the phenomenon? This is also a useful check to think about whether or not the questions actually are, the activities are actually the most useful for getting you what you need. So that's the what we figure out column. And also think about issues of navigation, right? So thinking about how are you going to create that green text on, at least on our weather storyline, how are you gonna be able to help kids see the connections for how things, you could be leveraging things from your previous understanding, but also how it fits into the broader goal. And this is the place where actually you might realize across these two kind of checkpoints that you might need to identify additional questions or activities, or there might be some sub questions that you might need to wrestle with to help kids be able to develop that coherent understanding. So again, this is a planning tool to support your purposes. But again, there might be some places in which you might need to create a need to deepen their understanding or to revise their ideas. So one of the things that we try to use in Open SciEd, and other structural materials have used this as well, is move towards problematizing by asking kids to use and apply their ideas and recognizing they can't fully explain that new situation in some way. So again, it's from their perspective. So you noticed before, right, in the performance expectation, there was the area that was blocked out, right? We can't yet talk about complex interactions of air masses with that hail phenomenon, but it's super productive in getting us a huge part of that performance expectation. So what we've decided to do is when we redesign the units in our release version, we create a second bend, a second half of the unit that really talked about large scale precipitation events. So we actually present a large storm that actually took place over the course of the entire United States. We asked kids to use and apply the ideas from the hailstorm model, but then that's where they see the limitations in their model. And that's what helps to get to that other part of the performance expectation. So again, thinking about your storyline, your big phenomenon, think about it in chunks. Organize your storyline over different chunks, but then also create the space for you to re-anchor if needed. So this anchor of so we actually watch a weather forecast will anchor the rest of the unit to help them to think about these large scale interactions and also think about global implications. So those are the 4 questions there. The 5th question that we have teachers think about is the opportunities that kids have to monitor and revise their ideas over time. So again, thinking about after each of the different investigations, we have a tool called a progress tracker. There are 2 different versions of this, but they would have it at the front of their notebook where they would have their lesson question and then the kids, what they figured out. Again, it can be new words or pictures or whatever it makes sense, but it's a tool for them. It's a tool for them to document their thinking in a formative way. It is not supposed to be assessed, but to help the kids take stock of what they learned. But there might be some critical moments in which like you engage in some really important ideas and you need to make sure everyone has the same understanding or at least similar understanding. So there's a 3-part progress tracker. where we actually do this together. They might do it first. We might talk about their ideas and make sure everyone has their ideas down and the evidence is used to support those ideas. So again, we use that structure to kind of same section of their notebook, but we use it in a way to help kids kind of take stock of what they have learned. And then we use the model trackers that then help them to revise their ideas when we engage in the putting the pieces together routine. Again, helping to see connections between lessons and ideas that they've learned. There's a strategy that Mark Winchell and his team use, which is called a gotta have it checklist, where the kids think about what are the ideas, components, features they need to include in their models. But then the move towards creating this diagrammatic representation, again, is to help them to see the pieces across the different ideas and how those ideas connect to one another. We also couple the putting these together routine with revisitation of the DQB. So here are some of our Nebraska friends around our DQB and thinking about some of the questions that we've answered. So we might either choose to take that question down or actually put another post-it with our answer to it on the DQB to kind of represent, track where we are as a team, but also to see what is it that we have not yet answered. And that kind of helps to motivate the next piece of the learning here. So in conclusion, right, so here are the 5 questions. It's a lot of work. Like, it's not, I'm not trying to say it's the easy peasy thing, but the great thing is that you have friends that you can work with together that can help you to think about how this work can be done together. But you'll notice there are keywords that are in bold here on this slide. It's about the students. It's all about them. It's not about us. It's about them. So that's why we do this work, because we want their learning to be meaningful. We want them to be engaged in the work. So these are 5 things again. So there's lots of different tools you can use to kind of get in the nitty gritty, right? But having these 5 questions at the front and center really helps to kind of frame the overall goal of the different phases that are helpful for, at least if you're going to be doing the move of trying to do this work on your own. I'm going to leave you with some resources. So again, OpenSite has 6 units that are released, 2 for 6th, 7th, and 8th grade, so 2 for each grade band. You can see a range of disciplines, the ways in which they are done differently, but they all have the same common features. That's what's helpful, at least for learning how to do this work. Next, in storylines, again, we use that instructional model in OpenSciEd, and they have examples from elementary, different middle school units. You can see we've adapted some of those units, and also in high school. And Inquiry Hub is also a resource that you can use for biology. I know they're working on the chemistry unit, but these are 3 of the kind of key players, at least who use the storylines model. They might give you a range of examples and to see how they differ across grade band. I think that's the cool thing to kind of look across. But there's my info. You can email me with questions. Again, I'll give Scott the link to that storyline planning tool that I showed earlier in a Google format that might help you to kind of think through some of your work. But I'm going to take a stab at taking your questions. So if you want to take some questions, I know that there were some things earlier that people had some questions about. So I'm just going to look across and maybe you can, Scott, and if you want to help me to think through some of these questions, any of the NATS folk too, if you want to point out some questions or themes to look across. But yeah, so if people want to take some moments to kind of jot some of the questions down, then we'll kind of look across. Is that all right?
Abe, there was a question about pacing and trying to stay on pace.
With teaching a storyline unit?
Yeah.
Super important, a struggle that a lot of our teachers have. And I think that one of the things that we work on in PD a lot is thinking about the goal of where we're going with this unit and having an understanding of how the lessons all fit together helps you kind of think about how much time you really should be devoting to the different things. And again, a lot of that comes from experience, having taught the lessons, but it's also something that we negotiate in professional learning. There is some guidelines. So you guys get the benefit of the released units that we've actually trialed this with a whole bunch of teachers. So we're pretty confident, at least with the first half, because we rewrote the second half, at least for the weather units, when we revised the unit. So we're pretty confident with our timings. But still, I think it's still a struggle. So I don't want to dismiss that. But having an idea, the writers at least have given you some guidelines for at least the relative timing of the chunks. Like the first time you lead the anchor found routine, it's supposed to be 3 days, right? And like Wanda and Kathy had mentioned in the past, right? Like having that space to think through and do the anchor properly is super important, because the whole storyline really falls apart if you don't devote that time early on, to devote that time to build that community, that structure, that culture of kids figuring things out. Because if you're doing this for the first time with kids and they're used to a more traditional scheme, they're not really used to, like, when people say we care about your ideas, some kids are a little skeptical. So you really have to be able to build that culture of trying, like, I legitimately do care about your ideas. And I think and being attuned to kids' questions and ideas helps you then to make decisions about your timing, right? Like the lesson plan might only say 15 minutes, right? But you know it's a really core idea, but you're hearing the kids are not there. So then you're not just going to gloss it over, right? You need to then take the time to think about where kids are, what are the hiccups, what experiences can I give them to not steal the aha moment from them, right? But to create that space for them to process their ideas.
I noticed Anya linked that ambitious science teaching gotta have it checklist.
Oh, thank you.
I'm gonna put a plug in here real quick that Mark Winschittel is actually going to be our keynote speaker at our conference next year. It's September, October. So.
Awesome. Betsy asked about questions are driven by design challenge. So our 6th grade thermal energy unit is driven by a design challenge, where the focal practice is it's an engineering PE or SCP. So the kids have presented with the situation, right? So it's Maurice is trying to convince me that I need to spend $30 on buying a really fancy cup to keep my drink cold. We actually try to look at the data, try to explain why that cup works better than another one. Think of the design features. Again, all using the science, and then we then have a design challenge where the kids actually develop a cup using everyday materials that can still have the same function, but a lot cheaper. Are there many worksheets to accompany the tasks? Yes, we provide a lot of tools in Google Doc forms, so you can edit them accordingly. You can use Google Classroom to use the strategies. I don't know how many worksheets is too many, but we do provide the tools. I'll say that. We provide sufficient tools to guide, and then you as a teacher can then decide which resources are helpful to move your thinking forward. Let's look at some of the questions that people have.
Taylor, I'm gonna answer your question. You had how do you safeguard if you have teach several sections that students in the first section don't tell them in the second section? I always start at the beginning of the year with that and say, hey guys, let the other kids come across this on their own. And you can even use the don't steal that aha moment. How much fun it was for you guys to learn something. Let the other classes have that moment. Give them advice as to what they can share. Like, hey, we're doing something with hail today. You don't have to tell them what was happening with hail.
Do other people have questions? You don't have to put them in the chat. You can actually save them if you want. Turn your video on or what have you.
So you have 2 units, like for 8th graders, for example. So exactly, I mean, obviously that wouldn't span through a whole year of content. So I guess how do you go about that? Like, how do you work them in or anything like that?
So each of the different units has particular content focus. So if you go on our website, there's a scope and sequence that kind of helps you think about where these different ideas fit, how they're designed. Because we're going to be constructing units that have 6 units per grade level. But there are also some guidance in the front matter of each unit that kind of tells you what we're expecting kids to build upon. And I think that knowing that context is super helpful for them thinking about where in our existing material that you're teaching, where each of the different things would fit most appropriately. I guess would be my suggestions, but then taking some of the different strategies that at least you've seen here that are evidence, you can begin to think of how you might incorporate some of those different things into your existing materials. Again, it's a marathon, right? Like you're not going to spend all the time to rewrite every unit because that might be overwhelming, right? But to think about what is it that you can take away with you, right? Like just the shifts or a strategy that you think might be helpful, and operationalizing that might be helpful. Ashley asked about hands-on labs to accompany. So all these activity investigations are hands-on with particular learning goals, and there's a variety of those different activities. All on the website, there are materials lists. Many of them have links to the resources, so you can actually purchase them on your own. So we vetted this material. There's also a lab provider, at least for our release units, called Aquaphoenix, that will buy them for you, send you pre-produced kits.
Hey, Abe, it's Betsy.
What's up?
All right, I'm gonna see if I can ask this question the right way. I had put it in the chat before. So as you were talking about whether a particular phenomenon was going to be productive or not, you crossed out parts of the DCI. So are there, when you are designing your units and you feel like, part of a DCI is not really needed for a kid to explain the phenomenon, do you just leave it out, or do you find a way to work it in, or how do you make some of those decisions?
So that crossing out was for a purpose to show that the anchor of the phenomenon that we chose for that first bend was not going to get to that part.
Okay.
So then we have to make the decision about what one is it needed, and we felt that it was needed. So that crossed out portion was going to be addressed in the second half of the unit. At least when we were field testing it, we didn't have time to do that part. But again, you have to make those decisions about is there something that you're just not going to be able to do in a coherent way, and just acknowledge what it is that you're not doing, and then to do it a different way if you need to do it. As designers, then we make it very public with our audience about what our design decisions were and why, so that people can make particular accommodations. But for that particular slide, it was to show when we make decisions about appropriateness, like we acknowledge the weaknesses, and then as you say, it's a decision point, right, about how we're going to address it.
So, and is it okay, so like in your teacher guides where you say there's a part in there that says, where we are going and where we are not going? Yep. Is that part of that, or?
Yes, yeah. So okay. If it's a crossed out part of a PE, we would talk about that more in the front matter. The where we're going and where we're not going. So every lesson has that section for every lesson. It helps teachers kind of get the scope about what is the target goal for that particular lesson, knowing that either some ideas are going to be developed later on. Gotcha. So to think about that, it's okay. So it's the purpose of bounding the expectations of the teacher. So again, to not steal aha moments from kids, knowing that something's going to be addressed later on.
Thank you.
But also acknowledging the grade level appropriateness. Like my daughter was watching a video about weather, and there are things that were not grade level appropriate, right? So that we would tell people that that's not the purpose of this lesson.
Thanks.
Mm-hmm.
I have a question about I loved how you said like creating a science culture. So I'm starting at a new school next year, and I am going to be the only science teacher there, and I am coming off of them having 87 years of teaching experience that I'm replacing. And so I'm trying to create a new culture that's like this and not quite what it was before. And so what would be some keys? Like, I really like that philosophy, I guess, kind of looking at it in terms of sports a little bit. And that's how you have successful sports, is having a good culture. So like, what are some keys you would say, like, okay, it's your first day, you're a new teacher. I'm trying to create this new science culture here. What are some things that you would do or say to your kids to kind of get that started?
I'm gonna offer one idea, and then I'm gonna ask others to kind of chime in, because we have a lot of expertise in the room or in the chats. I would just be really upfront about how it's different, but I would actually show them how it's different by actually doing some kind of science. So a lot of people have some very intro to science kind of things. They're doing a fun activity that doesn't necessarily connect any of the science. But I think the best way in which you can show that things are really different is actually by doing something that's different. And we have these classroom norms that we have with Open Syed. So in all of our PDs, we kind of start with the first column, right, with our 4 larger things, categories: respectful, equitable, committing to our learning, and moving our science thinking forward. And we actually talk about, like, why are these things necessary? What does it mean to actually engage in this norm? So we won't necessarily show at the onset what's on the right-hand side. That's kind of an elaboration. But sometimes something that we try to model is actually unpacking with our students, like, what does it actually mean to do this, and why is this important? And to keep coming back to them. It's not something that we always just bring up at the front and we never come back to. And again, that helps to kind of remind people about what we're up to and why. And I think those reminders are super important. Would anyone else who's add anything to Taylor's question?
I totally agree, Abe, that role modeling, having them, or even having kids go through it and show what they think it looks like, and then have others agree or disagree and really talk about it. And the beginning of the year is perfect for doing this. I'm coming from an elementary mindset here. So I had the advantage of, I was doing a lot of these things in quote my morning meeting. So it was like, okay, so how does this look now in science, and actually doing it in science? So hope that helps.
Thanks, Kathy.
Taylor, I'm going to say the same thing Abe said, that you've got to come back to these same, anytime you teach your kids something, go back to it and teach it again, whether it be the how to do the DQB or what the classroom norms are. The more that I went back and made sure they understood and they used it over and over again, the better we got in our classroom. If I assumed I taught it once and moved on, and I said, okay, we're doing a DQB, my kids didn't get it. I had to go back and refresh. What does that mean? Why are we doing this? And that helped a lot.
I would just say, be willing to share your enthusiasm. Just like, get excited about what you're learning along with your kids. It's kind of some of those intangibles, but just and be willing to share when you don't know the answer to something, and think out loud with your kids. So I don't know, just kind of some of those, like I said, intangibles that aren't necessarily on a list anywhere, but when you're excited and you show your passion, or you show that you don't know and it's okay to not know, that really I think helps build that culture too.
Any other questions? Oh, and we also remind ourselves really explicitly right before we go to the scientist circle, because it's about the first time we're all going to get all these people together in a circle to actually care about what people think. It's a great place to kind of like, hey, we have these norms. Like, if we're trying to accomplish this goal, which of these norms do we think are really important for us to really focus on right now? Both as a group, but also maybe perhaps individually. We have this cool activity where we actually sticky dots, like periodically, where we actually, how do you think we're doing as a community? And like, we have a chance to kind of say green, I think we're good. Yellow, we're working on it. Red, like, we're a hot mess. We need to figure this out. And we can then create that space for us to kind of talk a little bit about it as well. Are there any other questions people have?
Ooh, I did have one, Abe. It's Betsy again. So you talked about a part of the process being that unpacking. Does Open Syed have any tools for unpacking that might be helpful?
I could probably share a template. I know the Next Gen Storylines group has available what they have shared with teachers for unpackings. I might go there first. But what we have is very parallel in terms of like we actually have the language of the PE, and then at the disciplinary core idea, SCP, and the cross-cutting concepts. And so you'll note when we did looked at the foundation boxes underneath the performance expectation, I don't remember what slide it was, but it kind of talks about the elements of the practice or disciplinary core idea that was super critical for kids to know about. And then we actually done the unpacking related to that elements. And that's kind of what we do for unpacking. And then we do it first individually, and then we kind of share across within our design group to think about, to kind of come to consensus about what it is that we want kids to actually, and we use that unpacking to then derive our model ideas list that we want kids to develop by the end.
All right. Well, Abe, thank you very much for spending your time with us today. We
was a
have
pleasure.
Kathy Renfrew will be on tomorrow. Thank you everybody for spending your time with us, and hopefully this has been a great series for you, and we're excited to continue doing it. Thank you again, Abe.
All right, take care, guys.